Alright, so the chain rule is a tricky one. It actually is applied to a lot of different derivatives, like I'm saying here, even with like the simple derivatives like x squared, you still have the chain rule where you bring 2 down and you reduce the power to 1, so you get 2. You leave the inside of that alone, which is x, and then you take the derivative of that, which is just 1. You don't have to keep writing the 1s, but it is there. Generally, if you want to take a look at this, what we're trying to do is kind of peel back the layers and see, we're going to do one derivative at a time. If we look at this example, the composition of f of g is f of g of x, so we put the root x inside the place where we have u in the u cubed plus 1. And the way I like to do this is kind of like write out the different layers. Like the outermost layer of this function is where we have something cubed plus 1, right? And if we do the derivative of that, we get 3 times whatever's inside of there squared, right? And then on the inside of that, we have root x, but I'm going to write that as x to the 1/2, right? And we do the derivative of that, we end up with 1/2 x to the negative 1/2, right? Because it's really critical when you're doing chain rule to make sure that you're doing just one derivative at a time. And so when we approach the f of g prime, right, the first thing that we're going to do is apply the derivative that we have here. This is first, right? And we're going to get 3. The inside of our parentheses as we do this technique does not change. So since we had root x inside the parentheses here, right, we're going to keep it inside parentheses after we do the derivative, right? So we're going to have root x there, right, and then squared. After you're done with that derivative, right, so we can kind of check that off, right, then we can go on to the next line, right, and so we're going to multiply by 1/2, right, and then x to the negative 1/2 is just 1 over root x, right. And that's what the derivative looks like. Obviously, you can clean this up quite a bit. Root x squared is unnecessary. It's just x, right? So we get 3x over 2 root x. And we can cancel out root x, and we get 3/2 times root x, right? And what they're asking us to do is solve when x is equal to 1, right? And so if we look at f of g of 1, the whole thing prime, right, this would just be plugging in 1 for x, and you get 3/2 times root 1, which is 3/2. I'm going to continue on, so that's about 3 minutes, but I'm going to continue on to 34 because I'd like to do just 2 examples at a time. It's a little bit hard to see initially. The composition here, right, f of g of x, right, so we're going to go 1 minus 1 over, right, and then we replace it with 1 over 1 minus x, right. In this case, I'm going to choose to simplify first, right, because it's really, it's not really that necessary to do all the steps if they're unnecessary. And so it's not applying the chain rule because that would require a lot more steps, but if we flip this fraction up to the top, we actually end up with 1 minus x, right? And that's why you want to think about not just having tunnel vision and going for the chain rule all the time, right? This actually simplifies to just 1 minus 1 plus x, right? So your composition is simply x. And the derivative of that is really easy, right? It's simply 1. So f of g prime, right, would just be 1, and obviously that's a constant, right? And that would be your answer to 34.